In this episode, we're going to talk about automation in a way that is friendly to beginners and realistic for modern security, especially when AI is involved. Automation sounds exciting because it promises speed, fewer mistakes, and less repetitive work, but it also carries risk because automation can spread a mistake just as quickly as it spreads a benefit. Low-code tools make automation even more accessible because they let people build workflows using visual steps and simple rules rather than writing traditional software. That accessibility is great for productivity, but it can also create dangerous shortcuts if the workflow touches sensitive data, security decisions, or system actions. The heart of this episode is learning how to apply safe automation by adding guardrails and ensuring auditability, which means you can prove what happened, when it happened, and why it happened. For new learners, you do not need to build anything to understand this. You just need a clear picture of how an automated workflow can go wrong and what design habits reduce the chance of harm. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Automation in cybersecurity is any setup where a trigger causes a set of actions to happen without a person manually doing each step. A trigger might be an alert, a new login, a new file appearing, or a request coming into a queue. The actions might be collecting information, creating a ticket, notifying a team, blocking a connection, or applying a policy. Low-code automation usually means these triggers and actions are connected through visual blocks or pre-built connectors, and that makes it easy for non-programmers to create powerful flows. The risk is that power can exceed understanding, where someone connects steps that seem harmless but together create a dangerous chain. For example, a workflow that automatically shares a report might accidentally include sensitive details, or a workflow that automatically blocks an account might lock out the wrong person at the wrong time. Safe automation is not about avoiding automation. It is about designing it so that it fails safely and so that people can review and correct it quickly. Guardrails are the rules and controls that keep automation from doing something unsafe, especially when conditions are unclear. A simple guardrail is a limit, like only run this workflow on non-sensitive data or only take action if multiple conditions are met. Another guardrail is a checkpoint, where the automation prepares a recommendation but a human must approve the final action. Yet another guardrail is a constraint on scope, like only making changes in a specific environment or only for a specific set of known systems. Guardrails are especially important in security because security decisions often affect access, availability, and trust, and those are areas where mistakes can be costly. AI can make automation more tempting because it can generate suggested actions or classify events quickly, but AI can also be wrong, which means you should treat AI output as input to a guarded decision, not as a final authority. When you build automation with guardrails, you are basically saying speed is valuable, but safety is required. Auditability is the ability to trace an automated workflow after the fact and answer questions like what triggered it, what steps it took, what data it used, and who approved or changed anything. This matters because when something goes wrong, the first thing you need is clarity, not guesses. Auditability is also important for accountability because security actions can affect people and systems, and you need a record of why those actions were taken. In the real world, auditability supports investigations, compliance, and learning from incidents. But for beginners, the simplest reason is that it helps you fix problems. If you cannot see what an automation did, you cannot confidently correct it or prevent the same mistake from happening again. Low-code workflows can be especially risky when audit logs are weak or scattered, because the workflow might appear simple on a screen, but it may call multiple services behind the scenes. A safe approach treats logs and traceability as part of the workflow itself, not as an afterthought. To make this more concrete without getting into tool-specific details, imagine an automation that responds to a suspicious login. A naive version might immediately lock the account and block access, which sounds protective but could be abused or could disrupt legitimate work if the signal was a false alarm. A safer version might first gather more context, like recent login history, device information, and whether the login matches the person's typical pattern. then it might apply a rule that if the risk is high and certain conditions are met, it will take a limited action, like requiring an extra verification step rather than full lockout. It might also create a record for review and notify the right team. The difference is that the safer version does not assume a single signal is perfect, and it chooses actions that are reversible and proportionate. Guardrails keep it from making extreme decisions based on uncertain input, and auditability ensures that if it did make a decision, you can explain it later. One of the biggest beginner mistakes is assuming automation is either completely safe or completely dangerous. The reality is that automation is a spectrum, and different parts of a workflow carry different levels of risk. Collecting and summarizing data is usually lower risk than changing access rights or blocking systems, because data collection can often be reviewed before it causes harm. Automatically notifying a human can be helpful and relatively safe, but automatically enforcing a change can cause outages or lockouts if the logic is wrong. A useful mental model is to think about blast radius, meaning how far the consequences spread if the automation makes a mistake. Low blast radius actions are those that are easy to undo and affect few systems, while high blast radius actions are those that propagate widely and are difficult to reverse. Safe automation aims to keep blast radius small unless confidence is high and controls are strong. Another important concept for guardrails is input validation, which is a fancy way of saying do not trust the data that triggers the automation without checking it. If your workflow triggers on a label, a message, or a field value, you should consider whether that value could be wrong, missing, or manipulated. Attackers sometimes try to trick automated systems by feeding them misleading inputs, because if you can control the trigger, you can control the outcome. Even without attackers, inputs can be wrong because systems can have glitches or mismatched formats. A safe workflow checks that inputs are present, consistent, and within expected ranges, and it avoids making high-impact decisions when inputs are uncertain. This is especially important when AI is used to classify or summarize, because AI output can be plausible and confident even when it is wrong. Guardrails in that case include requiring corroborating signals or limiting AI-driven actions to recommendations. Change control is another guardrail that matters in low-code environments. Because low-code workflows are easy to edit, people can make changes quickly, and quick changes can introduce mistakes. A safe approach treats workflow changes like software changes, meaning you track who changed what, when it changed, and why it changed. You also want some level of review for changes that affect sensitive actions, and you want the ability to roll back if a change causes trouble. Beginners can think of this like editing a recipe that feeds hundreds of people. Small mistakes become big problems when the output is multiplied. Auditability here means having a clear record of versions and approvals, and guardrails mean controlling who can edit workflows and under what conditions. When AI assistants are involved in suggesting workflow steps, change control matters even more because people may accept suggestions quickly without fully understanding consequences. A common misconception about guardrails is that they slow everything down and remove the value of automation. In reality, guardrails are what make automation sustainable because they prevent painful incidents that cause teams to disable automation entirely. Another misconception is that auditability is only for compliance or legal needs, but auditability is also for learning and improvement. If you can see how a workflow behaves over time, you can tune it, reduce false alarms, and make it more reliable. Without auditability, every issue becomes a mystery, and people start relying on informal memory, which is fragile and inaccurate. Safe automation is not just building a workflow that works once. It is building a workflow that can be trusted repeatedly and improved safely. That trust is what allows automation to expand into more areas without creating constant fear of unexpected consequences. It is also helpful to think about safe failure, which means deciding what the automation should do when it is unsure or when something unexpected happens. If a workflow cannot reach a system it depends on, does it retry? Does it stop? Or does it take a default action? If the data it expects is missing, does it assume the best or the worst? Attackers sometimes take advantage of default behaviors, and accidents can also produce unsafe defaults. A safe design usually prefers stopping and alerting a human over taking an aggressive action based on incomplete information, especially when the action is hard to undo. Safe failure also includes designing workflows that degrade gracefully. meaning they still do something useful, like collecting context and creating a record even if they cannot complete the full set of actions. This keeps defenders informed without letting automation create extra damage during uncertainty. As we close, the key lesson is that low-code automation can be a powerful ally in cybersecurity, but it must be designed with guardrails and auditability from the beginning. Guardrails limit what automation can do, define when human approval is required, validate inputs, and control blast radius so mistakes do not spread widely. Auditability ensures you can trace triggers, steps, data, approvals, and changes, which supports accountability and makes improvement possible. AI can enhance automation by helping classify events and suggest actions, but it also increases the need for caution because AI can be wrong in ways that look convincing. When you approach automation with a safety mindset, you get the speed benefits while keeping control of risk. The goal is not to eliminate automation, but to make it predictable, reviewable, and safe enough that you can rely on it even when conditions are messy and attackers are trying to manipulate your systems.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.